All right, we'll get started here. My name is Chris LeSueur. I'm a product manager at Esri. I've been working for the last many years and working with mobile and app development products at Esri. And with me, I'll let my co-host here introduce himself.
Thanks, Chris. Mike Branscombe, product manager supporting our native Maps SDKs and our game engine Maps SDKs.
All right, this afternoon, we're going to talk about, as you see from the title, strategies for mobile and desktop development. Before we get started, I like to kind of poll the attendees here. Who is when someone asks you what your job is or what you do for a living, who would reply that they are a developer or a GIS developer? Or by raise of hands. Who would? Okay, pretty good. Who would maybe qualify themselves as a what I sometimes refer to as like a geohacker, can, have some GIS skills, learn some code, can kind of copy and paste code and generally figure out how to get things done. Anyone fall in that space? Okay, we see some people here. Good. And who's a GIS analyst, project manager, or GIS manager? Anyone fall in that space? Okay. So not as many, but we have a little bit. Good, it just gives us an idea of, gives myself and Mike a little idea of who we're speaking to here. So this session is an overview of the options available for building mobile and desktop applications. It's really to help you narrow your research. An example, should you be using web? Should you be using native? Or maybe help you on what specific product you should be using. Should you be using Experience Builder to build your application? We aim to be transparent in this presentation. We want to talk about the pros and cons of our technology. There's a lot of different factors that go into what technology you should choose, and we're going to talk about some of those considerations that you might have when choosing a technology. And really we're here in this session just to guide you in that decision-making process. We will not go deep and specific into any particular product. This is an overview. So if you're here, if you already know, you're a Swift developer and you want to learn a little more about the Swift SDK, this is not the session for you. This is definitely an overview of the offerings that we have and really to guide you and help you and maybe make a decision for you and your organization on what you should build on. We will be taking questions at the end from the audience, as well as those that are online. We ask you can type in your questions. We will be looking through those. We will hope to answer a few of those at the end, as well as some from the audience here. So the title of this is mobile and desktop development, but really we should consider this as kind of a spectrum of devices from, multiple monitor heads-up displays to laptops, to tablets, to phones, to now things like AR and VR headsets. There's a wide range of devices out there, and you might need to choose the right tool to target those specific devices. There might be multiple options for going on the desktop, for going mobile, and you need to focus, what's important for you, what's important for your situation, the context that you're building in. And there might not be a perfect solution that fits everything that you're doing, but we definitely want to, help you make those decisions. We will say that there's a good chance that, after going through this, that there might be some new technology that you're going to need to learn. And that's a good thing. It's always good to learn new things and to up our developer skills. Speaking of developer skills, one of the most important, considerations when choosing a technology to build upon is existing developer skills. What developer skills do you have experience with, or maybe others in your organization have experience with? What developer environments do you want to use? Do you have access to? What does Esri offer? Hopefully, ideally, those things line up, right? You've got some experience or you have some training or someone in your organization does in a specific language, and Esri also offers a tooling in that specific language. We hope those things line up, and we do our best to, in talking to our customers to line those things up. Our CTO, often says we try to meet our developers where they are, or our users where they are, meaning what they're using, what they're wanting to use. We try to meet them there. An example of that is the newly announced SDK for Flutter. A lot of feedback from our users that was something they were interested in, and after hearing that and talking with them, we now announced this new SDK that we'll be supporting in the future. You might need to do some retraining depending on the solution you choose, and right, we know that the cost of training is not just monetary, what you pay for the training, but the time away from your projects, the time away from other work you need to do, getting others on your team sped up on it. But that's, we feel that it's almost always a good return on investment. You almost always will see, that's beneficial to you. And at Esri, we do the same. Group members of the team will move from one product to another. They'll move from working in one language to another. And it's just a good opportunity for growth and career movement. So some development considerations. Obviously, it kind of goes without saying, we need to think about the end user in the beginning. We need to think about, what use cases this app might solve, what problem it's going to solve, what are the expectations from that user, how are they going to get it, how are they going to acquire it, how are they going to use it, what platforms it needs to be on. Is this now a desktop application, but you see going forward that it might very well could be a mobile or a tablet or smartphone application. So need to think about that end user, where they're going to get it. Is cross-platform, right? As I mentioned, is cross-platforms important? Is it going to be used by different people on different types of devices? And I'll talk a little more about cross-platform development in the next slide. How are we going to distribute this? And this actually sometimes will be, if you start, it almost is something that needs to be started with. How is this going to be distributed? Is this going to be something just for your organization that is going to be, pushed out as a regular install that they go download, or do you have a mobile device management system maybe? Is this just going to be a website that they're going to access? Or does it need to go into one of the public app stores, Google Play or the Apple App Store? And that will determine a lot of what you're going to choose to develop on, depending on how that's going to be distributed. So if you know that right up front, that will help narrow things down. Licensing from Esri, our developer tools, I think pretty much all of them are, we don't charge, there's no license charge to use them and develop with them. But the services they connect to, whether that's ArcGIS Online, ArcGIS Enterprise, how you authenticate in and get access to data, get access to capabilities, there is licensing to be considered there, as well as there might be licensing for the development tools that you're actually using, such as something like Visual Studio. There could be licensing considerations that you have. So cross-platform. We have this idea of native platform APIs, or as we talk about them and the industry talks about them, there's things like .NET. .NET is a native platform API for Windows. Swift is an Objective-C for working in iOS. So those are great and great for building tools, but when you maybe need to hit multiple platforms, multiple operating systems, cross-platform becomes a really viable option. And with cross-platform, writing that application once and then being able to compile or deploy at least to those different other platforms, there's often a functional or a gap, a technology gap. You can usually get most of it done, but there might be some capabilities you don't have access to. An example would be maybe you don't have the latest libraries for doing AR or VR work and being able to anchor your objects into specific places. That's I know it's one example coming from the Apple and Google world. Those things might come to the cross-platform, but they just, and a lot of features will come. It just takes a little longer. So keep that in mind, that if you go cross-platform, you can build some great applications, but you might not have every single, I guess, access to every single library right away that you need. Also, if you choose a cross-platform solution, as far as on the native side, there's often, almost all of the code is kind of reusable, or majority of it, particularly like the business logic. But there might be a case where you need to write some custom code. You may need some platform-specific code to maybe connect to a specific device, maybe to change the UI to align with that platform and some of the requirements there. When we look at deployment options, or really I think of development patterns, with Esri, automating is big. We see people doing things, they want to automate processes, and they often use the ArcGIS API for Python for that. Extending existing applications like ArcGIS Pro and ArcGIS Enterprise, changing the user interface or connecting to another system. And then creating new applications. We have things like the Maps SDKs, our native map SDKs, Kotlin, .NET, Swift, Java, Qt, and now Flutter coming in beta. We have game engine technology, web with JavaScript, also some builders on the web with dashboards, instant apps, and experience builders. So we have a wide variety of tools for our development options. Last one is working with some open source tooling like OpenLayers and Leaflet to connect to Esri services. So we're going to focus on today, we can't touch all of these. We're going to talk about ArcGIS Pro SDK. We're going to talk about native app development, game engine development, web with JavaScript, and web with Experience Builder. With that, I'll jump into the ArcGIS Maps SDK for JavaScript. So this is a modern JavaScript, access to a modern JavaScript API, and really a modern JavaScript software development kit for working and building WebGIS applications. It supports both 2D and 3D visualizations. So being able to create 3D views as well as that top-down 2D view. And these are data-driven, meaning that the pattern is create that map, create that web map, put all that beautiful symbology, intelligence into the web map, and now you can create a great experience where you can create applications and ask questions like where, what, how much, and when. Really create great applications from that mapping GIS data. It also supports things like smart mapping, so being able to really create some beautiful visualizations, create also charts, some tools to create some beautiful charts and bring those in as well. And as you probably saw from demonstrations yesterday, or if you go to our JavaScript in the expo, you'll see some really nice looking applications you can build with our JavaScript SDK. We're talking this about building apps for desktop and mobile with JavaScript. So they have done, especially in this latest in the 4x JavaScript API, they've really really focused on responsive user interface design. So giving tools so that your application looks great on a desktop, but also will scale down to a mobile device. And they call this like the mobile first design principle. So thinking about mobile from the beginning, thinking about make sure that you can access all the tools, view the map, click on everything you need to from a mobile perspective. So they put a lot of work into that. With the JavaScript SDK comes a lot of tools for rapid application development. So there's over 50 widgets, and now there's also over 50 web components, as they described yesterday. A new kind of a modern and common practice way of componentizing these web development tools so that you can easily put a map, a legend, do measure and things inside of your application with writing a little less code, but at the same time having a great ability of a great amount of flexibility to be able to customize them. We also have the rich pop-ups, which get kind of hydrated from the web map. So you can put charts, images, information right into the web map, and that will come through in your JavaScript application. And then we have Calcite, which is our design language. If you build around that, you can have really great, consistent look, right out of the box with your applications and how they're styled. So jump to the pros and cons of using the JavaScript SDK. Pros, it's cross-platform, meaning it runs inside a browser, and if you have a modern browser on your device, your app should work there. It's easier to learn than other technology. I mean, we typically hear that if someone's coming out of new to development, JavaScript is a little easier to pick up and work with than maybe jumping to .NET or C# or Objective-C or another language. I'm not saying that's everyone, but that's often we do hear that and see that from our community. The latest web technologies provide really great performance, and our team is always looking at ways to make that better, whether that's caching data or prefetching information and showing that. We have those great tools, those web components for that rapid development, and changes are immediately seen by the end user. That's a big plus. You make a change, you write, you save, you publish your application. Someone just needs to refresh, and they have the latest version right there. The cons, while performance is good, it's not typically quite the same as a native application. Particularly, we see that on mobile apps and how we interact with the user interface. It doesn't support all of the peripherals that you might want to, like GNSS receivers, barcode scanners, RFID scanners, things like that. It is connected only, so if your application needs to run offline, it's not the tool for you, and it's not possible to go to app stores. So if you have a requirement that what you're building needs to go into a the Google Play Store or Apple App Store, obviously JavaScript SDK is not the solution for you. Will not go. You can't publish an app and go into app stores with it. So another web technology we have for building apps is Experience Builder. ArcGIS Experience Builder is our low-code, no-code tool for creating web experiences. And that could be a single web application, a single page, a single application that you work with, a single map with tools, or it could be a multi-page application. So you're building a whole, kind of that single-page experience over a multi-page experience. It does both. It includes tools and templates to make you productive. So these tools and these templates, the templates particularly, you hydrate them with your information, your images, your colors, your text, and of course that map, and then boom, you've got a nice looking web application. It's built on top of that ArcGIS JavaScript SDK. And because of that, you get great symbology. Your maps are gonna look great. It's gonna perform fantastic. It's gonna be kind of get that latest technology in there. And because of that, it supports both 2D and 3D maps. If you want to, it is a low-code, no-code, or a no-code to begin with, just configuration experience, but there is the ability to create custom widgets, to write some code and create these custom widgets, which then you can use in your apps and or you can share with others, and they can build apps with that custom widget as well. They've spent a lot of time with Experience Builder making sure it does kind of work on all sorts of different sizes of screens, and done a great job with it. Mobile, tablets, desktop, all of their templates that they provide are all optimized for mobile, to work on mobile. And with this mobile adaptive design, they kind of have two ways of doing it. There's the synchronize with desktop or auto, so as your large screen kind of shrinks down, you'll see things move around a little bit. You'll see things optimize into a nice place on the screen, and you'll see them look like it belongs on a mobile screen, and kind of just elegantly shrink and expand as your screen would. Or you can create a separate custom layout. So with a custom layout, you're basically telling it, hey, if this app was running on a mobile device, totally change the layout if you want. You can rearrange and resize the widgets. You can change the content that's inside them. You can use less widgets or swap them out and have different widgets. So it gives you kind of full control of how that application works when on a mobile device. And just the same as a JavaScript API, as far as the Pro is concerned, it's really the same, most of the same things that we saw with JavaScript API. It runs in a browser, it's cross-platform and such. Another Pro that's unique though is that you don't have to write code, right? You can just use the configuration experience if you'd like with your application. So no code needed. Also, developers can build those custom widgets if they'd like, which can be used by their apps or share those widgets with others that embed them into their apps as well. Some of the cons, while performance is good, it's kind of like JavaScript. It's not quite the same as having a native application. Again, those peripherals, if you need to connect to the GNSS, GPS receivers, barcode scanners, RFID, and others, if you need to connect to those, and directly through Bluetooth or other ways, you typically wouldn't have the same amount of access and capabilities. It is connected only, so it runs inside a browser. You can't go offline. And it's, again, not possible to push these apps to an app store. So that is JavaScript SDK and Experience Builder. With that, I'm going to turn the time over to Mike, who's going to talk about some of our native SDKs.
All right, thanks, Chris. So this section continues the same pattern as the first part of the presentation that Chris just took you through. So we're taking a product-centric view of the developer options that are available to you for building desktop and mobile applications. Just as Chris did for each of the options that we take a look at, I'll cover the purpose, the benefits, development considerations, and then the pros and cons. But there's a notable switch in the session here because we're switching from technologies that use web technologies or web-based products, and we're switching to look at a variety of products that use platform APIs for creating applications that run directly on desktop or mobile devices. I'll take you through to the end of the session, and then we'll have a Q&A at the end. If you're watching online, please feel free to submit questions via Pigeonhole, and then obviously we'll take questions in the room as well. First of all, let's consider our ArcGIS Maps SDKs for native apps. So the native Maps SDKs are a group of SDKs. They're dedicated to building native applications for desktop and mobile apps. They use platform-specific APIs and cross-platform APIs. When talking about these products, we use the term native quite a lot. Here we're using native to differentiate from web applications and applications that are built with hybrid or web native technologies. So these native apps are installed directly on your device, on your desktop or mobile. They're built with platform APIs from vendors like Google, Apple, Microsoft, or Qt company. And they're compiled using these core platform APIs into apps. So the purpose of the native Maps SDKs then, it's all about integrating with existing business applications that you have, so incorporating mapping and spatial analysis into those existing applications, or you might be building a brand new application from scratch. We talk about the native Maps SDKs as providing the best mobile experience. That's partly because they are built using native platform technologies, and therefore you get the most kind of interactive, responsive experience. You get the benefit of that app running on your device. Some of the benefits like that include the ability to be offline, so give you a more responsive experience. It also, as in terms of the developer, the native Maps SDKs give you a great mobile development experience. They integrate well with the integrated development environments, the IDEs that you use to build these applications. They can also take advantage of GPU resources on device. And as Chris talked about, native applications have the ability to access additional sensors and peripherals that you may connect to the device. Note the native maps SDKs support multiple platforms. So the APIs that you're developing applications with support a wide range of desktop and mobile operating systems. And then also the APIs or the SDKs integrate with a range of popular development environments. And really one of the biggest differentiators for the native maps SDKs over some of those web-based technologies is the ability to power offline workflows. So the ability to take data offline from the ArcGIS system or add data directly from the local device. So it could be a range of vector and raster formats that you're accessing. It could be packages, data packages such as mobile map packages or scene layer packages that have been published from ArcGIS applications and either sideloaded or downloaded to the device. But that ability to power these offline workflows is one of the biggest differentiators. The APIs, the native maps APIs, also include a range of analysis tools, geospatial analysis tools that run directly on the device. So effectively, they're running offline. There's a geometry engine. Then the API also provides the ability to geocode, to perform routing and generate directions, determining line of sight, view sheds for visibility analysis. And all of these are able to run directly on the device offline. Of course, they can run offline with connected services as well. And then the SDKs, of course, work well with the rest of the ArcGIS system. So they enable you to build great standalone applications, but then they also integrate seamlessly with the rest of the ArcGIS system. And so that means connecting to services. It means authenticating as a perhaps as a named user, for example, within ArcGIS, and then working with portals, working with content from ArcGIS Pro, from ArcGIS Enterprise, or ArcGIS Online. So in terms of the native maps SDKs, there are 5 SDKs. So SDKs for .NET, Java, Qt, Kotlin, and Swift. These provide a range of cross-platform SDKs. So .NET, Java, and Qt provide cross-platform options, and I'll cover the different platforms they support in a moment. And then Kotlin and Swift are platform-specific for Android and iOS, respectively. One of the benefits of the native maps SDKs that we talk about is they're built on a common C++ runtime core. So that's essentially where all of the GIS logic is for 2D and 3D rendering as well, but also data access, routing, geocoding, and more. Underneath that is support for 5 platforms. So the Android, iOS, Windows operating systems that these SDKs support, and then underneath that, rendering APIs and ultimately architectures. So a range of platform-specific and cross-platform SDKs. The key about, the reason why I'm telling you all about this C++ runtime core is that these same ArcGIS capabilities are available in each of these native maps SDKs. So you're choosing essentially based on the language that you want to develop your applications with, or the environment you want to develop your applications with. You get the same ArcGIS capabilities in each SDK. At this conference, we're excited to be announcing a new Maps SDK for Flutter, and essentially that kind of highlights again the benefit of that common C++ runtime core that we're building on top of. So it's relatively straightforward for us to add a new SDK. I say relatively, it obviously means spinning up new teams and investing in a product that will have a multi-year life cycle. So relatively easy, but it's still a significant investment. But we've got significant feedback over the last few years that a number of you want to work with Flutter, and so we're excited to be adding a new Flutter SDK. One of the key things that you'll be choosing which of these native SDKs to use based on is the language or the development environment. So if it's .NET, it's C#, Java, you've got the choice of Java 17, 21, and the Java FX UI framework, Kotlin, Qt with C++, and then Swift or Swift UI. So typically people choose their native Maps SDK based on the language that they want to develop with. But then the other factor that plays into this is obviously the platforms that you want to target as well. So .NET as a cross-platform option supports Android, iOS. Windows, it also supports Mac OS with Mac Catalyst. If you're using the Java SDK, then it supports Linux, Mac OS, and Windows. So again, cross-platform there. Kotlin primarily supports Android. And then Qt actually is the only one of our native Maps SDKs to support all 5 of these operating systems. And then Swift, primarily iOS, but also Mac OS with Mac Catalyst. So again, really it's a combination of those 2 factors. It's which platforms do you need to target, and then what are your development skills and experience. Other factors that help you when choosing one of these SDKs, are you integrating with an existing application? So if you're bringing the API into an existing application framework, then that often determines what you're choosing. So if you have a .NET application that you're already building, then you're most likely to choose the .NET SDK. Who will be using the application? So what operating systems, what devices are they running on? Are you, as the developer building the application, do you get to control the hardware that your users are running those applications on, or is it more of a bring your own device, or more of a general public environment where you don't necessarily have control over the devices and you have to think about broader operating system support? Who's building the applications? That's really about what the skills are of the people building the application. Some of the development considerations then for the native Maps SDKs, what's the technology stack that the actual underlying platform itself is built on? So .NET, Java, Qt. These platforms are all built on technology stacks. You may, for example, need another component from another vendor, a third-party component for connecting to a device or a peripheral. And you have to think about, is that component that I need available within this technology stack, within this framework? Are you building platform-specific or cross-platform applications? If you're building cross-platform, is the underlying cross-platform framework that you're using, .NET, for example, or Java, Qt, does it expose all of the underlying platform APIs that you need to use? And then what about consistency with the native UI or native UX? So within cross-platform SDKs, some of them enable you to build applications that are completely consistent with the native UI on that device. So a button on iOS looks like a button, as you would expect in an iOS application. Other cross-platform SDKs give you more consistency across, essentially within your application, across all platforms. So your application looks the same on each platform that it runs on, but it doesn't necessarily look consistent with other applications running on that specific platform. What about authentication? One of my strongest pieces of advice is identify which authentication methods you need to use and you need to support early on, and then ensure that those are available in the environment that you're targeting, the operating system, the platform that you're targeting, and the SDK. So by authentication methods, I'm talking about things like OAuth or PKI, certificate-based authentication. So some of the platform APIs have implications for which of those methods are available. What's the HTTP stack that the underlying platform is built on? So often this, excuse me, often this plays into the authentication area as well. So often the authentication approaches that are available to you will be determined by the HTTP stack. And then again, third-party libraries, probably a good one to re-emphasize just is what's the availability of third-party libraries that you may also need to bring into your application. Are they available on each of the platform APIs? Are they available on the operating systems that you're targeting? And then what about the underlying actual platform licensing as well? So our ArcGIS SDKs typically are free to develop with, but the development environment that you need to use to build those applications. If you're working, for example, with Microsoft Visual Studio or Qt Creator, often these environments will have licensing of their own that you need to take into account. And that's depending on whether the application you're building is a commercial project, or maybe it might depend on the scale of the application in terms of the number of developers you have, something like that. All right, so what about pros and cons for the native Maps SDKs? So the best mobile experience for users, most responsive, most interactive applications, best experience for developers, great IDEs, great APIs, great resources. Cross-platform options for targeting multiple different operating systems. The native Maps SDKs. Native Maps SDKs, excuse me. The native Maps SDKs enable you to distribute your apps via app stores. The native Maps SDKs are free to develop with, although, like I said, think about the actual licensing of the IDE or development environment that you may be using. And then there are multiple deployment licensing for applications that you build with our SDKs. So we support both license strings if your application is going to essentially be completely offline, or you're deploying it to users that they don't have named users or known identities within the ArcGIS system. But you can also license applications having a user sign into ArcGIS. What about some of the cons of the native Maps SDKs then? You need experienced developers to build these applications. So to build robust, supportable, well-tested applications, you need good, experienced developers. And you may also be developing an application from scratch. So that means many things. It means obviously application design. It means an infrastructure around that. It means testing the application. It means planning the life cycle of that application. So we talked about our native Maps SDKs. Let's move on to take a look at our ArcGIS Maps SDKs for game engines. So we built the Maps SDKs for game engines to bring GIS data into game engines. We target the two industry-leading game engines, Unity and Unreal Engine. So they're designed primarily for you to build immersive 3D GIS experiences. So that's augmented reality applications, mixed reality applications, and virtual reality applications. The SDKs are free to download and develop with, just as our native Maps SDKs and JavaScript as well. They enable you to work with high precision in real-world coordinates inside the game engines. And that's highlighted because game engines typically didn't support the level of precision that you need to represent GIS data anywhere in the world. So we had to work with both Unity and Epic games to ensure that we could represent GIS data with the level of precision we need anywhere in the world. And then these SDKs still integrate with the ArcGIS system, of course. So it's connecting to services from the ArcGIS system, or it's consuming packages from the ArcGIS system. People often ask us, why are you targeting game engines? And one of the first responses there is premium rendering experience. So the game engines in the world of gaming is a highly competitive industry. So these game engines have been rapidly advancing in terms of the level of rendering, the high fidelity rendering that they offer. And we were able to bring GIS data to life in that environment. Physics, animation, and special effects. So physics, animation, and special effects are all about creating a believable, immersive environment for your application. Across hardware development, the game engines support multiple platforms. Both Unity and Unreal Engine support multiple operating systems for you to deploy your applications to. And then there's also a massive existing game engine developer community. So that means there are many assets and plugins available for you to bring in to the game engine development environment and enhance your application. So in terms of the premium rendering experience, then here we're seeing an example of Unreal Engine, and this is just an integrated mesh, but the game engine provides these highly realistic rendering of the asset. We can see beautiful lighting, we can see the reflections, materials, and then, of course, that weather system and the kind of environment and the atmosphere in the background. And then in this case, two more examples here. These are integrated meshes, but when the weather system's running there, you can see flashes of lightning and the light is bouncing off the buildings. That's kind of just the participation of this integrated mesh inside of the game engine. And on the right-hand side, you can see a rooftop, and you can see rain splashing on the rooftop. Again, that's just acting as a mesh collider within the game engine. But the physics, animation, particle system are providing these weather systems. And this weather system in this example is just an existing plugin that's been developed by a game engine developer that you can bring into your application in the IDE and easily add realistic weather effects. So what about the requirements for mobile and desktop development with the game engine SDKs then? So both Unity and Unreal Engine have a low-code, no-code experience. So that's kind of, to some extent, out of the box in the IDE, but we integrate with that. So our SDK provides the ability to configure your map, add layers, define the spatial reference, define the base map, and start manipulating some of the layers through low-code, no-code tools. Unity provides extensibility and development with C#, and then Unreal Engine has a visual designer system called Blueprints or C++ API. And then in terms of the operating systems that they support, with Unity, you can target Android and iOS, macOS and Windows. Unreal Engine provides the same support. Notably, both Unity and Unreal Engine do support Linux. We don't with our SDK at the moment, but we are considering it as an option for the future. So if you want to work with Unity or Unreal Engine to build your application and you need to deploy to Linux, then we're keen to hear from you. So what about development considerations? Well, these SDKs were first released in June and July 2022, so not quite 2 years old. And what this means is that there's still relatively new SDKs within the ArcGIS system, so not all ArcGIS capabilities and layer types are currently supported. That said, we do release significant new capabilities with each release, so they're rapidly catching up with our other SDKs, the native SDKs and the web SDK with JavaScript. So you need to match your requirements with the current capabilities of these SDKs then, and also the roadmap, our roadmap for where we plan to advance these SDKs in the future. What about pros and cons? So one of the pros of the game engine SDKs is the ability to build these immersive extended reality experiences that weren't previously possible. You can exploit the full capabilities of what is possible on a mobile or extended reality device. So those two examples that I showed with the high fidelity or premium rendering experience, but also the weather system plugin to bring in realistic weather, and then full capabilities in terms of the ability to participate in that kind of mesh collider and have that realistic, believable experience. And then the existing game engine developer community. Some of the cons then, it may mean learning a new technology. Traditionally, the GIS industry isn't used to working with game engine and game engine development environment. So it may mean learning new skills, learning new technology, or even hiring additional developers. And then, like I said, there is only a subset of ArcGIS capabilities and layer types are currently supported. Okay, so our final SDK option that we're going to take a look at is the ArcGIS Pro SDK. So the ArcGIS Pro SDK is an extensibility SDK for the desktop application ArcGIS Pro. It's designed with specific extensibility points and patterns, and there are actually 4 options. There are add-ins for ArcGIS Pro. There are configurations of ArcGIS Pro. You can build plug-in data sources, and then you can even create and run core host applications. So these provide a variety of customization options for ArcGIS Pro. The most common development pattern by far is to build an add-in. So you use add-ins to extend the capabilities of ArcGIS Pro with new tools and new workflows. So essentially, you're customizing the UI of ArcGIS Pro with a new tool or a new dialog. They're easy to distribute with the Esri Add-in X model, And administrators can even control the distribution or the installation of these add-ins to restrict it to add-ins from your organization. The next step up from add-ins is to develop a configuration. So configurations are a higher level of customization, where add-ins are customizing the existing UI of ArcGIS Pro. Configurations can go much deeper. The configuration is invoked as soon as the ArcGIS Pro application starts, which means you get to do things like have your own splash screen. So if you want to kind of brand it as an organizational application with your own organizational brand, then you can use a configuration to do that. So Esri uses configurations to create a set of products on top of ArcGIS Pro. When you're developing with ArcGIS Pro, one of the things to think about is you need to target the current or the corresponding version of ArcGIS Pro. So the current version 3.3.2, then when you're using the current version of the SDK, that's the version of ArcGIS Pro that you're targeting. Supports both Windows 10 and Windows 11, Microsoft Visual Studio 2022. There's a minimum .NET version of .NET 6.05. You get to take advantage of all of the nice features of the .NET language, so async tasks, link, WPF binding, MVVM development pattern. Both C# and VB languages are supported. And then there are many different templates available to you within Visual Studio, buttons, tools, menus to speed up and enhance your development. So your development using the ArcGIS Pro SDK, then it's dependent on ArcGIS Pro. So you have to think about licensing. You as a developer will need a licensed copy of ArcGIS Pro to build and test your kind of extension of ArcGIS Pro. And then your users will also need ArcGIS Pro as well. I mentioned that dependency on ArcGIS Pro releases, so the version of the SDK that you're using determines the version of ArcGIS Pro that you're deploying your add-in or configuration to. The deployment size, obviously ArcGIS Pro has a sizable footprint on the device. That's maybe something to bear in mind about the hardware that you're running on. And then if you're thinking about automating workflows, so not just manual interactive workflows, but automating workflows, then think about using Python rather than an add-in. So pros and cons. One of the pros is there is a large existing user base that are familiar with ArcGIS Pro and the concepts of ArcGIS Pro. You're building on top of a powerful GIS application as the foundation. But some of the implications are the development costs. So you need to think about licensing of ArcGIS Pro to run your application on your development machine. And then you're working within the ArcGIS Pro framework. So you're not building a custom application like you might do with the native Maps SDKs, but you're essentially customizing ArcGIS Pro. Okay, so let's move on to a review of what we've been talking about. So before I do that, there are some notable deprecations and retirement plans that we think it's worth mentioning here. So the ArcGIS API for JavaScript 3x retires in July this year, 2024. Web App Builder also retires in July, and then when it's part of Enterprise and part of ArcGIS Online, there are specific retirement dates there as well. ArcGIS AppStudio retires in February 2025, so another year to go. And then we've recently announced the deprecation of the ArcGIS Maps SDK for Java, and that planned retirement is in November 2028. So it was the deprecation of the Java Maps SDK was just announced, so it's got a 4-year life cycle to 2028. But as we saw, we've introduced a new SDK there with Flutter. So in terms of your choices then as a strategy for building desktop and mobile applications, we had the ArcGIS Maps SDK for JavaScript. We looked at ArcGIS Experience Builder, and then we looked at the Maps SDKs for native apps, the Maps SDKs for game engines, and the ArcGIS Pro SDK. So a product-centric view of different options for building applications and all of the considerations and then the pros and cons in each case. Ultimately, You'll want to review all of the options that are available to you and then match those with your user requirements and your business requirements. We hope you enjoyed the session. We'll have a Q&A in a second, but please share your feedback about the session. Was it what you expected? Was it not what you expected? We'd love to hear feedback. Connect with us on social, and then let's move to a Q&A. So we've been running the Pigeonhole system here, so we'll be able to take some questions online, but we're also able to take questions in the room as well.
Yeah. Maybe real quick, we'll just go through. There's just a couple of questions here on Pigeonhole.
Okay.
One is, ArcObjects still exists? And I know it's in extended support as currently, and I think it will fully retire it in 2027, but it's currently in extended support, meaning it's not being verified on new platforms and such. So yeah, don't start new ArcObjects projects.
Yeah. So yeah, I suppose in terms of ArcObjects, traditionally that was used for building custom desktop applications with ArcGIS Engine, and the natural replacement or the natural successor there is to look at the native Maps SDKs. ArcObjects was also used for customizing ArcMap, and the natural successor there is to look at customizing ArcGIS Pro. And then you could also use ArcObjects for customizing ArcGIS Server or ArcGIS Enterprise. And there your migration path is to look at server object interceptors or server object extensions with ArcGIS Enterprise.
Another question maybe for you, Mike. Do we need desktop license to run apps built with native Maps SDKs?
No, you don't need a desktop license. The native Maps SDKs has its own licensing model. We cover this in the developer documentation. There are a series of license levels from a free, light license right up through basic, standard, and advanced, and the additional capabilities are unlocked at each level, and then there are extension licenses as well. So an analysis extension license and an advanced editing extension license will be coming up. And then when it comes to licensing the native Maps SDKs, you can either apply a license string. For example, if your application will never be connected and you're deploying it to users who don't have named or they don't have ArcGIS identities, then the license string approach is a great option. But if you're deploying within an organization where there's an existing ArcGIS implementation and there are named users, then users can sign in, authenticate, and they can unlock or get a license from their portal to unlock the application that way.
And then one more from online. I'll just read it. I don't have the right answer, but it has the most votes. So with Experience Builder, is there a plan to start supporting Arcade? Sorry, myself or Mike, where neither of us are on the Experience Builder team, I don't know the exact plans. I know that there's limited support within things like forms, and the forms and the logic you can bring into forms to Arcade or into field maps, those work. But I know this is something that's highly requested. I've reached out to the team and looking for an answer, but no, I don't know the exact answer to that yet.
Okay, so that was 3 online. Should we
take let's take
one in the room?
Yeah, from the room. Anyone have any questions?
There's one down there from.
Yes. So you're asking what should we use now that we're taking off? Did you say AppStudio? AppStudio, an AppStudio. Okay. Oh, we did. Okay, and I did that personally, actually. So you're not. So if your organization is using AppStudio, and we did remove the downloads from the website, but if you go to our FAQ in the Esri Community, the downloads are still there. We're basically trying to dissuade new organizations from using this because of the timeline. But yes, you still have to migrate. So you can. The downloads are still available. They're just in a different location. I can show you exactly where they are. Then the Esri Community, the FAQ, the retirement FAQ for AppStudio has all the downloads there. And even if it's a new hire that hasn't used AppStudio previously, but because your organization is using it, yes, you can still use it for the next year as you maintain and migrate your application. Great, yes, yeah, you still have access to it, yeah. Any others? Oh, over here.
We're interested in making detailed 3D models of electrical stations. And do the game engines offer an advantage if you're on just a desktop computer over like a 3D scene? Is there more that you can do in terms of like rendering, or is it really only if you're using like a VR headset?
Okay. So the question is, do the game engines offer more when modeling a 3D scene than maybe are there 3D tools within ArcGIS ecosystem? You want to?
Sure. Yeah, actually, that's a great question. We see a lot of users starting to use the game engine SDKs for building desktop applications because they like the additional rendering capabilities that the game engine provides. They might have a number of 3D models that they want to bring into that environment. So yeah, it's totally possible to build desktop applications, and we do see people doing that. We were trying to, I suppose, position the game engine SDKs as specifically more about immersive experiences, augmented, mixed, and virtual reality. But yeah, desktop applications are actually a common pattern with the game engine SDKs. And we don't currently support web scenes, but we do support a number of the 3D layer types from the ArcGIS system, with building scene layer being one of the new ones, which might be appropriate in your use case, I think.
Yeah. So a big advantage of the game engines is, right, there's already game engine assets out there. There's already trees that flow in the wind and vehicles and things that are just readily available and really realistic that you can build into your models. Those other things aren't really as readily available within the other Esri 3D ecosystem. Any other questions? No? Let me check online one time.
Any more online?
I think this one came in maybe before you talked about it. It says, could you please explain the retirements and their impacts for this upcoming year? But I think that was probably before you ran through it at the end of the presentation there.
Okay.
So we did talk about the major retirements and plans for the end of the year. All right.
All right. If there are no other questions, thank you for joining us.
Yeah, thank you all.